In this video, we're going to learn about vectors for lesson number 2 in Physics 1. What exactly are they and why do they matter? To answer such question, we first need to understand between scalars and vectors. For scalars, it tells us how much of something there is, or in other words, any quantity that has a magnitude but no direction. Such examples are 20 degrees Celsius for the unit of temperature, 250 kilocalories for the unit of energy, 90 kilometers per hour for the unit of speed, 1.8 meters for the unit of distance, and 10 seconds for the unit of time. In comparison for the vectors, we describe it as any quantity with both magnitude and direction. Such examples are 90 kilometers per hour east for the unit of displacement, 500 newtons straight down for the unit of force. Vectors are represented graphically by arrows. If the arrow is pointing to the east or to the right, it is positive. If the arrow is pointing upward or to the north, it is also positive. Now, if the arrow is pointing downward or going south, it now becomes negative. If the arrow is pointing to the left or west, it becomes negative. By doing so, we use the Cartesian coordinate system. We have the x-axis for the horizontal component and the y-axis for the vertical component. Let's now answer a sample problem. You fly 45 degrees from the x component to a helicopter for 20 kilometers. You turn 30 degrees from the x component and fly 15 kilometers. In what magnitude and angle direction are you from the starting point? So how can we answer such problem? So first, let's create a graph. So in order to measure the degrees of turn, we use a protractor. So let's place it at the center of the origin, aligned to the x-axis. Next, let's strike a 45-degree angle following the yellow color in the protractor. Let's have a sample arrow here. And then let's measure a 45 degree. Okay, so now we have a 45 degree. Let's just try to resize it. Great. Now, let's label the first arrow as vector A. And we write the vector A with the value of 20 kilometers with 45 degrees. Let's proceed to the next value. So our origin starts here, but let's change the angle. Let's align it using our protractor and measure 15 degrees. Let's label it as vector B. We label vector B with 15 kilometers and 30 degrees. So this line here with color yellow is the resultant vector. Let's label it as vector R. So how can we compute for the resultant vector? In order to find the resultant vector, we use this formula. R is equals to square root of rx squared plus ry squared. In order to find for the resultant vector in the x-axis, we just add ax plus bx. For the resultant vector in the y-axis, we use ay plus by. Let's proceed in finding the resultant vector in the x-axis. As you can see, we use the cosine trigonometric function in finding the angle in the x-axis. Let's substitute the given values into our formula. A is equals to 20 times cosine 45, 15 times cosine 30. Let's compute. So ax equals 20 times cosine 45 equals 14.14. For the bx, (15 times cosine 30), 12.99. Let's add these two numbers. 14.14 plus 12.99 equals 27.13. Let's save this later. So let's continue with the y-axis with existing given. We use the formula ry equals to ay plus by. We use the sine trigonometric function in computing for the y components. So we substitute the given using the formula a sine theta, and for the by, sine theta. So 20 sine 45 and 15 sine 30. So 20 sine 45. So it's 14.14. Next, let's compute for the by. So 15 sine 30, 7.5. Now let's add the two using the formula ry is equals to ay plus by. (14.14 plus 7.5) we get equals to 21.64. We will use this later on the next computation. So now we use the Pythagorean theorem computing for the resultant vector. So we substitute the Rx and Ry with 27.13 and 21.64. Let's compute. Square root 27.13 squared plus 21.64 squared. So it's 34.70. We're not finished yet. So let's now compute for the angle. We're done with the magnitude. So for computing the angle, we use the sine theta again. But this time, we use the arc tangent or tan negative 1. So Ry is divided by 2Rx, then multiplied to tangent negative 1. Let's compute. 21.64 divided by 27.13. And then, we multiply tangent negative 1. So shift, tangent, answer equals 38.58 degrees. The final answer is 34.70 kilometers, 38.58 degrees from the x component. So that's it everyone. Hit like or dislike, feel free to subscribe for future physics tutorial videos. Thank you for watching.